my name is Ashley. This is my presentation on air pollution impacts on the COVID-19 lockdown in California with Dr. William C. Porter. So with the COVID-19 lockdown, we have so many people had to stay home. So many people had to take their classes from home. People had to work home. So that just meant that traffic was a lot less compared to before. And we can actually see that there was a primary transportation emissions that reduced up to 58%. Right here on the upper right, we can see that there was a picture that was taken on September 29. That was a pre-COVID-19 era, right? And that was at 7:30, where we can see it was kind of really hard to see the city. However, here in March 22nd, we can see that the skies are much clearer, and the picture was actually taken at the same time. So this just kind of shows how much of an impact we humans have on our surroundings, right? So we just have to kind of ask ourselves, what can we learn about causes and spatial patterns, exposure disparities of air pollution from this perturbation of human activity? So in our study, we decided to look at three pollutants. They're called particulate matter 2.5 and particulate matter 10, or PM 2.5 and PM 10, and ozone. Particulate matter, there's two types, right? So as I mentioned before, 2.5 and 10. 2.5 is usually released through combustion and is much smaller than 10, which is usually kind of spread around through wind, dust, and pollen. It's really easy to inhale, which is why it has posed as cardiovascular and respiratory. It can cause respiratory and cardiovascular problems. For ozone, that's produced through heat, sunlight, oxides of nitrogen, and volatile organic compounds, all of which have been also known to cause reduced lung function and basically cause a lot of respiratory issues. So the reason why we're actually more interested in studying the impacts that the COVID-19 lockdown had on air pollution is because of this paper. And this paper looked at a variety of disparities across socioeconomic status, this disparity of specifically NO2, and it looked at a variety of categories such as household income. Here on the right, we can see that the orange dot represents the lower income and the blue dot represents higher income areas. The solid line represents the pre-2020 era or period, and the solid line represents the 2020 time period, right? And we can actually see that there was a downward shift in NO2, which means that, the air actually kind of got cleaner in regards to NO2. However, it's also kind of disturbing to see that the lower income regions still continue to have higher levels of NO2 compared to the higher income levels. We were also looking at this other paper by Hao Yin, and this paper basically highlights how complex air pollution chemistry is, right? Because here we can see that, here in the bottom, we can see that the blue bar represents PM10, PM 2.5, or O3. And the red line basically represents non-meteorological factors such as human activity, and the yellow bar represents meteorological activity, and meteorological activity is referring to weather, right? So here we can see, and this is all compared to previous years. So in PM 2.5 and PM 10, we can see that their respective pollutants were decreased, as well as when human activity decreased, right? However, here in O3, we can see that the opposite kind of happened, where ozone increased, even though we saw an increase in ozone and we saw an increase in meteorological factors, which we can kind of conclude that meteorological factors had a bigger impact in O3 here. So what our objective is that we are going to analyze and compare air quality changes that occurred during the COVID-19 lockdown by location, land use type, region location, and socioeconomic status to levels prior to the lockdown for the purpose of this presentation, we're going to solely focus on land use type and socioeconomic status. We hypothesize that the inland and high poverty rate regions will experience less air quality improvement during the COVID-19 lockdown because of how close they usually are to traffic hub areas and warehouse facilities. So how did we do this? We use this EPA, this database called EPA. It's basically a tool that kind of just collects all of the surface level measurements of various air pollutants. And it can also categorize their stations through urban, suburban, or rural base. What we chose to look at was PM 2.5, PM10, and ozone. And what we also did was we also chose data that had above an 80% increase, above an 80% data over 10 to 15 years. And these are where our stations that we chose are located around California. And we also use another tool called CalEnviroscreen, which basically compiles all demographic data by census tract, which allows us to kind of see where our stations are located and the median income of those specific stations. As I mentioned before, our focus for this presentation is going to be median income. What we did after we compiled all these data sets was that we had to filter out and clean for what we were trying to look for, right? So we had to filter out for PM 2.5, PM10, ozone, and according to our land use and demographics. So our land use was going to be suburban, urban, and rural categories, and our demographics were going to be below median income and above a median income. And after that, we just kind of visualize and analyze means that we created graphs that would allow us to look further into trends. So here we have one where up top, we can see that the red line represents 2020 year, and the gray area behind that represents the 10 years prior, and those are superimposed on each other. We can see that we decided to focus on the months of March and April just because that's when California decided to have their lockdown. And we can see that there was actually a decrease in PM 2.5. However, there was actually an increase in PM10, and ozone just about stayed the same according to our box plots. However, the reason as to why there was such a difference in, compared to PM 2.5 and PM10 is something that we're still going to look further into. So here's where we have our median income. Here on the left, we have our below median income, and on the right, we have above median income. And we can see that in both areas, there has been a slight decrease in PM 2.5, a slight increase in PM10, and about the same, no difference in ozone, right? And the reason for this, as I mentioned before, as to why air pollution is behaving this way is something that we still are trying to look forward into. So what we actually found was that PM 2.5 concentrations were lower during the lockdown, but ozone showed no significant difference, while PM 2.5 concentrations were actually higher, as I mentioned before. And in income types, we saw that PM 2.5 had big drops, while PM10 had an increase was greater in high income regions. So what we're going to look at next is to continue to examine the land type and regional differences in order to look into meteorological variability, fire emissions, and other factors in order to understand why 2020 behaved the way it did. And I just want to give a quick shout out to the Porter Group, especially Dr. William Porter, Rise, and Persist with Dr. Sue Wessler and Dr. Connie Nugent. And that concludes my presentation. Thank you.